Okay, in this unit, we're going to look at unsupervised learning. If you remember, in machine learning, there's two basic types of learning: supervised learning and unsupervised learning. Supervised learning is what we've been looking at so far, and where we have a set of inputs and we have a sort of outputs associated with that. So we can train the neural network or whatever network we have, model we have. Given this input, you should generate this output. Given this other input, you should generate this other output. So it's kind of supervised. It's kind of like flashcards. You're told an answer that you want to learn here. Now, unsupervised learning is when we have a set of some data and we don't have labels or categories for that data. And then how do we want to group that? So that's what we're going to look at here. There are a couple ways of doing supervised learning. The main way we'll be looking at is called clustering here. So we'll split data into different clusters and assign data to different clusters. So for example, we might have observations of planets, exoplanets, and we want to characterize them different classes of planets. We don't even know what types of planets are out there. We just want to classify them. We might have customers and we want to classify clusters of customers together by their purchase history or their credit history or something like that. Hospital patients, we may actually characterize hospitals. I've done some work with hospitals and looking at their patient outcomes and then grouping groups of hospitals together that way. Now, similar to this, but slightly different, is association mining. So association mining is where we find similarities. We look for specific similarities between their feature sets and find that. So we might find association with customers or products, so we can recommend new products out there. Similar, we might find associations between patients and related medical conditions, so that when we often see if patients generally have this medical condition, might also have this other side effect or issue, related medical issue. We might, when a customer comes in presenting like one thing like a heart attack, we might recommend, oh, we should run these other tests because these often show up in conjunction here. So we can look for that kind of association mining. Another thing we can do when we're clustering or kind of working with this stuff is look for outliers, or in this case, anomaly detection. So if we had a set of data, are there some data elements that really stand out as separate from this? This is often used in credit card fraud detection. SETI uses this for radio signal identification for extraterrestrial signals, possibly for when they're looking through the radio telescopes. We've seen this used looking at network activity, try to identify hackers coming into the college for things. So again, the basic idea is that we have some sort of group of objects here, and we want to try to cluster them together into different clusters is the main way, but we have different ways. We'll get to that in a sec. Let's jump to this article. This is an IBM article talking about unsupervised learning. It gives a good overview of unsupervised learning. So again, the common approaches they talk about is clustering, and then you can either have them exclusive or overlapping. The question is can one sample be in more than one cluster? We'll be using k-means cluster, which is an exclusive cluster. So items will be in either one cluster or another for that. There's also hierarchical clustering. This is kind of similar to decision trees here, where we have a set of elements here and we break them down into different categories. So we have this big cluster, and in here we might see subclusters and subclusters of that here, and break everything down into a hierarchy. We're not going to look at doing that in code, but that's another way of doing this. There's also probabilistic clustering, and again, this is where we get into this idea of items can be more than one. We can have overlapping clusters with probabilistic clustering. So an item might be in two different clusters here for that. So association rules, we kind of talked a little bit, is how we can look for associations between items and so what we often do is try to build up some rules and association rules where if this, then this kind of rules. This is often used for like predicting if a customer bought this, then customer might also often buy this here. And there are some different ways of doing this. One is called a priori. And again, I'm not going to do any detail on this, but this is work with what are called transaction systems, and transaction systems are a series of purchases or other transactions that happen over time, and they're usually grouped by by person and product. And you say, well, this person bought this thing at one time and this at another time, and then we try to look at patterns, associations, and say this is what rank. What are some possible future transactions we could see? Now, another thing grouped in this is called dimensional reduction, which we covered last unit. And I pull this out kind of separate because to me it's not really unsupervised learning. It does some of the same things, but here they group it in the same thing, which you'll often see. So principal component analysis is often grouped in here, and then there's this other value, single value decompositions. There's actually a couple different other ways of doing a dimensional reduction here, but PCI is by far the most common one. So again, in that we don't have labels. We don't need labels for PCA, and we can do some categorizing of this. Now, when we get in images, we'll talk to, oh, sorry. And so, yeah, autoencoders are methods we'll look in neural networks where we'll look at inputs and outputs, and we'll come up with some hidden encoding here. They're often used nowadays for image processing to do automatic image processing or manipulations, and we'll look at a couple examples of that when we get more into image processing with neural networks for this. So this does go over some nice applications of machine learning that are used out here. There's a number of different ways. There's this whole area of now called semi-supervised learning, where you know a little bit, but you may not know exact categories. We're not going to go into that, but that's here that we can look at for this. So this is just a good overview of unsupervised learning. So next we're going to look at k-means cluster in the next video.